DuckDB has become one of my favorite tools of late because it's designed as an analytics database. It's supposed to do like millions, maybe even billion row queries quickly. And it's kind of in the same space as SQLite, so you could use it that way. But where it's found a place in my heart is it's great for dealing with kind of awkward data jobs. Like you found a hodgepodge of CSV files or JSON data, and you need to pull it in somewhere and start understanding what you're looking at, making sense of it. And maybe when you found an interesting query or two, spitting that out to a spreadsheet to send to someone else. It's superb at that. And for that reason alone, it's found its way into my everyday toolbox. But I know I'm only scratching the surface of what it can do. It's filled with little useful tools for that kind of job. So when a friend of mine said he was going to co-write a book full of all the different ways DuckDB can be used, I knew I'd have to read it for tips. And when I read it, I knew I'd have to bring him in to share some of his practical knowledge here. So, joining me this week to discuss a host of useful ways that DuckDB can be put to use are Simon Aubury and Ned Letcher, two gentlemen who've gone from using it to deal with social network graphs or awkward Hadoop clusters to putting together a whole book on how to make the most of it. And in this discussion, we're going to go through everything from SQL queries and Python bindings and R bindings to hosting DuckDB in a web page through WASM. Because does anything really exist these days unless it compiles to WASM? Before we begin on the podcast, I do have to do a quick full disclosure thing and tell you a quick story. So, a couple of months back, Simon contacted me on a Friday afternoon, and he said, would you be willing to read our book and write a foreword? And I said, well, I'll read it first, and then I'll decide if I'm writing the foreword. How long have I got? He said, the weekend. I said, you're kidding. He said, no, it's got to go to the printers on Monday. You've got the whole weekend. I said, well, I'll have to cancel my Sudoku plans, but sure, I'll do it. So I did nothing but read the book all weekend, and I learned a lot. I was very pleased, and I happily wrote the foreword and sent it off. Several weeks later, Simon and Ned sent me a bottle of red wine and a jumbo book of Sudoku puzzles. So we learned two things. Obviously, what I should have said was, I can do it, but I need to cancel my weekend plans. I was going to go hunting for vintage synthesizers. Might have got something more than a book of Sudoku puzzles. But the other thing we learned is if I can be bought fairly cheaply for red wine, interesting tech books, and puzzles. It's possible you knew that already. My real bias here is Simon's a friend, and I think he's a great guy. And having spoken to him now, I'm forming the same opinion about Ned. So I hope you enjoy listening to them. Let's get into it. I'm your host, Chris Jenkins. This is Developer Voices, and today's voices are Simon Aubury and Ned Letcher. Joining me today, we have two fine Australians, Simon Aubury and Ned Letcher. How are you doing?
Doing well. Great to talk to you today, Chris.
Yeah, pretty good, thanks.
Always good to have you back, Simon. I've spoken to you on other podcasts in the past. But Ned, you're my first-time guest, so maybe I'll start picking on you. So we had, to give this some context, we had Hannes Mulhuisen on the podcast a while back talking about DuckDB. And we mostly ended up talking about the internals going right down inside, which is fascinating. But it's also fascinating to ask, like, what can this actually do for me today? Which is why I've got you guys in. You've just written a whole book about it. But before the book was written, Ned, what did DuckDB actually do for you? Why do you care?
Yeah, good question. I think first of all, I heard a whole bunch of buzz about it. I sort of tapped into, the online data scene, Twitter. Now, it might have even been, yes, it would have even been Twitter back then. And just sort of suddenly, people that I pay attention to and trust were saying things like, hey, this DuckDB thing is looking pretty interesting, like really strong focus on analytical needs. And so I guess I was seeing data science folk and people doing data engineering and data analytics just saying positive things about it. So I thought, well, I should probably take it for a spin. And I did actually try it on some data I'd extracted from using the Twitter API while it was still affordable to mere mortals, and sort of pulled down a bunch of my social graph. I was interested in exploring what would it be like to sort of see clusters of people, visualize the sort of the network of little micro communities that form that you can't necessarily see out of the box. And so I pulled down all this data and sort of had this little scraper thing going, and I ended up with I think about 70 million lines of JSON lines data, sort of records, and then having to parse that and hydrate it, and ended up with a single DuckDB query. It came together, sort of loaded it and had it in a table in DuckDB in about under a minute, I think it was. And this was on I think version 0.7 or so before it's now hit 1.0 recently. So I have a hunch it's probably got even a bunch more performant. And this was just on my desktop. So I sort of like, okay, this is pretty cool. I'm going to have to check this out. And then Simon sort of said, hey, do you want to write a book about it? I was like, well, look, I've got to go deeper. I've got to go down this rabbit hole. So
yeah, we're going to definitely get into that collaboration. But I've got to pick you up on that. You said social graph, and that surprises me because I don't think of DuckDB as a graph database.
Yeah, out of the box, not so much. I think it was just more to do with the way that I got the data, and there was essentially a sort of you hit the API that sort of says, well, I follow people who follow this, follow that, and so there's a couple of chains deep, and so I guess I had essentially graph data, not in the form of graph data. I wanted it to become graph data, so my task was to hydrate it. I think I'll actually need some other tool to sort of do that graph style analysis. I think would be appropriate, but just as a first step of wrangling it into the right shape. And I think that's a really good, strong use case for DuckDB. Like you've got a pile of data, possibly quite big, really good with semi-structured data like JSON. And just sort of, getting it into that shape that you need for analysis.
Yeah. Wrangling is the word that comes to mind.
Yeah, that's
in my experience of DuckDB. Is that similar for you, Simon?
I think I came across DuckDB in a similar sort of slightly inquisitive way. It came across my radar as a tool that some people were talking about, some people were raving about. But I think I had my own sort of vanity project, which kind of got me interested in it. I wear a Fitbit, which collects a lot of data. And one day I just decided I'd download the big archive of data just to have a bit of an idea of what had been collected through my fitness tracking device. And it was really great to download this enormous zip file, which from memory was gigabytes in size. And then I was somewhat terrified when I opened it up and realized that, it was a mixture of weird JSON files and some CSV files. And it was just a collection of all sorts of things representing heart rates and step counts and location information. And I mean, it was quite extensive, but it was like 70,000 files all up.
Really?
And I thought, yeah, that was an awful lot of data. And I thought to myself, this is kind of cool, but now like they're not particularly standard. Some are with weird embedded American date formats. Some have actual epoch timestamps. Some have some just very strangely formatted JSON. So it was all over the place. And I thought, well, I'm going to give this new tool DuckDB a go, which is, one of its callouts is it's great for these sort of data wrangling things when you've got everything local. And I thought, well, I'm going to give it a go and start trying and playing. And long story short, I brought in what was essentially 20 styles of data really, really quickly. And it sort of convinced me that, for this kind of job of I have a bunch of data and I want to do something with it, and it's fairly undocumented or it's got some fairly rogue or unique encodings within it. I just found from that problem space to lifting it through to now I've loaded this data into a form that I can do some analysis on. That path, which I thought was going to be quite a long path, turned out to be a fairly straightforward path. And I think that was one of my call outs of experience with DuckDB was I had a job to be done. kind of anticipated the job was going to be difficult with lots of mucking around with Python formatters and stuff like that. And lo and behold, a lot of those problems were just sort of smoothed away. So I got to my job of making pretty graphs pretty easily.
Yeah. It's I think I realized it was a useful tool when I had some structured but weird JSON data. I pulled it in and spat it out to an Excel file. And I thought, well, that's a terribly useful thing I'll remember for work one day, because that's so common, right? But you guys have actually gone away and kind of catalogued all the different data formats out there. Ned, do you have a favorite?
I mean, well, it's always tempting to say it depends. It depends on your use case and what you're doing.
I think that's the unofficial motto of this podcast.
Yeah, right. Technology in general, or yeah, absolutely. But I think, I think the one that jumps out that sort of, a bit of a workhorse of analytical data applications is Parquet. And I think also it's one that, if you haven't come across it before and you're learning about it for the first time, it can be a bit mind-blowing what it can open up for you. And so I guess, some of the properties that, unlike, say, a text format like CSV, the schema isn't encoded inside that. And as, if you've had the pleasure, shall we say, of having to wrangle some random CSV that could be in all manner of different formats, having to potentially do some of those non-standard date conversions that Simon was talking about before. But if you have your schema built into the binary file, as you do in Parquet, you don't have to kind of keep solving that deserialization logic problem every time. So that's, one of the really great benefits, for example.
Right. Go into that a bit more, because I think of Parquet as it's kind of got the table definition and I think it partitions, but that's where my knowledge caps out.
Yeah, it's interesting. I think some of these things I've learned a little bit more. I think also probably worth mentioning that in the book, I think I've sort of focused a little bit more on some of the data science and analytics applications, and Simon is definitely closer to our resident data engineer. So I might pass over to you in a sec, Simon. But I think one of the interesting things that I learned was that the partitioning is a little bit orthogonal to what's going on in the file system. So with DuckDB, you can actually have partitioned CSVs if you're already, and JSON files, and get some of the benefits of, accessing only files within that partition in your cloud storage. Like you can actually get that from DuckDB, but perhaps if you're thinking about those sorts of optimizations, you're probably going to be looking at putting it into Parquet and getting some of those other benefits. Which I don't know. Yeah, Simon, do you want to jump in around? What are some of the things you like about Parquet?
Oh, I think you covered it nicely, Ned. But I think I think we all have our favorite file formats. But if I was to pick just one favorite child, it would probably be Parquet, which I think on the tin would say something along the lines of it's self-describing. It contains both the schema definition and the data itself, which sounds pretty straightforward, but is a sort of a nice side effect that you've got a single file, and within that file, it describes the data types of the columns, maybe some usage and some statistics of the data within. That makes it very straightforward if you've got data sort of sitting in a Parquet file, because you can just query it and find that what columns are integers and which ones are floats and which ones are strings. But because it's self-describing and it's got the schema and it's got a bunch of metadata within it, it has some nice side effects in that if you've got a lot of Parquet files sitting on a disk somewhere and you just want to query, I don't know which Parquet files have a user called Chris or Ned, the metadata at the top of the file will essentially have some the maximum and minimum values, and it lends itself to sort of efficient processing if you've got a smart enough Parquet reader, because it can essentially ignore a bunch of files that maybe do not have the word Chris anywhere within that file. It means that if you've got a smart enough Parquet reader, you can ignore those files.
And DuckDB is one of those smarter readers.
Yeah.
I think one of the things that I picked up from doing this deep dive is I think I'm finally able to talk about the difference between fancy words like predicate pushdown, which is what Simon was just talking about, where you send the filter, like the where clause, like, hey, I want some date between this and that, and if that's in a column, the metadata inside of the Parquet files can actually only go through certain chunks. Like it'll do some sort of search through maximum, minimum values. And so you don't actually have to read the full contents of that column. And then the other enhancement, the other optimization is the projection pushdown, where it's like, hey, if it's just in that username, for example, then if we're just doing select username from table, we can just pull down that username column and not other columns, which is really handy if it's a really wide table, lots of columns, and this is over in cloud storage. Using fancy HTTP requests, you can just get those columns. And so, when you're sending a bunch of data over the wire, anything you can leave behind is a nice win.
How does that work? Because that presumably does that mean you have to have a special server at the back end that understands Parquet?
Well,
that one is I forget the name of the HTTP type of request. Do you remember, Simon? But it's actually built into the protocol, and it is able to sort of look into, because the metadata is at the top of the Parquet file. So you can just sort of read enough of that metadata to go, I only need these columns. And this is where we get to the benefit of it being all columnar oriented. And so you might often hear terms like, columnar data stores or columnar databases, which DuckDB has that orientation. And so when you're talking about analytical applications where we're, doing things like summing and aggregating into averages and means, we do need to collapse down entire columns. And so that sort of access pattern, this is these benefits are really nice and elegant, and they've been designed in that way to do things like just sort of efficiently getting those single columns.
Yeah.
But how much of that, maybe you know this, Simon, but how much of that picking out single columns needs to be built into the server answering the request?
So that's a good question. Maybe we should just sort of orientate some of this in the maybe the experience, and then we can jump into the execution. I think one of the great things about all of this is it's fast. I think one of the things that we sometimes get caught up in is the technology and the implementation, but it's just worth orientating that the biggest efficiency you can have is not doing the processing at all. So if you can come up with a processing scheme that says, well, we've got 80 terabytes sitting on an object store, but we can be smart to work out where we don't need to look for data, we have made a massive optimization by just avoiding work. So this idea around predicate pushdown within a file or skipping a file if we know that the data is not going to be there is a terrific time saver because you're essentially avoiding unnecessary work. And again, I'll be straight up. I don't know the deep intricacies, but I'm going to make up words and say HTTP range request is.
But that's it. You got it. Yeah. That's the one.
Excellent.
I was trying to Google it in the background. But
No. So Ned's revealing far too much here. But the long story short here is that what you want to do is either completely ignore a file if you know the data is not there. And to what Ned was talking about before, if you essentially had a wide table projected into a Parquet file, and maybe you want the first column and the last column, you know that you can essentially miss all of the columns in between. And an HTTP range request is like a sort of a disk access request. You can basically just barrel through a bunch of bytes and then skip ahead and barrel through a whole bunch of secondary bytes, and just projecting that either through local disk or over a network. Again, if you're minimizing the work up front and then being smart around the bytes that you're retrieving, you've made the whole experience much faster by just doing only the necessary work.
Yeah, I guess to me it feels like maybe the answer to your question, Chris, is that it's a nice property of both some design features of the web, of HTTP, and also these analytical standards that like Parquet that have formed, and maybe as towards which of them sort of came first, and maybe co-evolution together. I'm sure there's some folks that have some more opinionated takes on that, but I think it's good design choices on both those sides working together.
Yeah. It's funny, all these years working with HTTP, and I didn't know there was a range request. Makes me wonder what other standards that are in there. Because I've never actually read the docs. I'm sure there's one person that has, that didn't write them, but I never... Okay, so maybe we've talked about going to the outside world. Maybe we should talk about where you've put DuckDB. Because I think I'm right in saying, Simon, you've used it at work for some curious projects. Is that true?
Yeah, that's correct. So I've used DuckDB in obviously a hobby capacity, but I ended up finding that this was a great sort of tool just in my day job. One small experience I had was I was once on a site. I was dealing with some very sort of sensitive medical data. It happened to be on a big sort of Hadoop cluster locked in safely in a data center. And my default position would be, if I wanted to do a lot of heavy processing on this sensitive data, wouldn't it be great to lift this into a cloud data warehouse and do it, how the cool kids do it? But because of the nature of this data, we weren't permitted to use it. So it was very much, well, how do I bring that sort of smart computation directly against the data? And that's in one of my first sort of professional capacities. That's where I found that, this idea of bringing computation directly to the data, having the benefits of predicate pushdowns and smart scanning, jumping over a whole bunch of sort of nested Hive partitioning. A lot of that is sort of fairly routine data engineering stuff, but to be able to do it locally and at pace with a sort of a free and open source processing engine was just magic. And the fact that you can just sort of point DuckDB at a Hive metastore and just say, hey, go forward and read this stuff and query it, just felt like magic.
So you're in that scenario, you're not moving the data around, but you're just replacing Hadoop as your query engine.
Essentially, yeah. So one of the great things about DuckDB is it's quite extensible. One of the, I think what is now a default extension is its ability to just sort of interact with object stores as long as it presents like an object store. DuckDB can sort of navigate over sort of quite nested Hive organized file systems, and that's pretty standard for Hadoop file systems. So in my case, it was like I acted like a genius. Again, revealing a lot behind the curtain here, but in my case, where I just wanted to chunk through a whole bunch of files, I didn't need to write like Hadoop batch jobs or write like Spark code. I could just literally, from my perspective, write a bunch of SQL statements pointed at the right object store, and I got the answers I needed.
And does that, I'm guessing that involves just saying create a local table which is actually virtually backed off by Hive?
Correct.
Like?
Yeah. So one of the great things about DuckDB is it utilizes memory quite efficiently. So if I wanted to, trape through, petabytes of information to retrieve gigabytes or terabytes of information, it's a fairly straightforward trade-off to, pull the data I want, put it into memory, and then do something in my case, in a temporary table in memory. The classic of aggregates and joins and distribution. It's straightforward SQL, but you're getting a lot of magic under the covers by simply using a SQL dialect, pointing at an object store, and getting a lot of heavy lifting done by DuckDB under the covers. And to your question, a lot of that just sort of materializes in memory as a table.
And you don't necessarily need to bring it in as a table, like whether it's a sort of a virtual or real, actual table. You can just do the querying you need to do off the source data system. So it does depend on how it's been organized. But as we were talking before, if you had all of your data in nice, clean Parquet and potentially Hive partitioned, you may find that your queries work quite well straight off of that. And depending on what you're trying to do, maybe you're trying to create some extracts, like wrangle it into, CSV, JSON, whatever it might be. You might be able to do that wrangling directly without sort of landing it anywhere. One of the nice, this potentially brings up some of the nice design features of DuckDB, and all the way through it sort of there's like lazy execution goes on, so you stream the operations through, which means that you can get some quite efficient queries happening, but of course it does depend on what you're getting up to, and maybe for what you need to do, you do need to create some tables and wrangle things, and maybe you've got different stages of tables. I think that's something I'm keen to get into a little bit more myself in my more sort of data science workflows. Actually, I think that's one of the neat things about DuckDB is giving you a bunch of these data management features, like a catalog of tables where I can start landing things, as opposed to say, having, export 1.csv, export 2 or export 3, .parquet lying around, and you're like, hang on, what does this file mean again? So that's, I think that's one of the other nice benefits. And I think if you read back some of the positioning papers, or sort of, why come up with DuckDB, that some of that Mark and Hannes talk about was enabling data scientists with those kinds of features. Hey, why can't data scientists have these nice data management features as well?
Yeah. It's because you mentioned speed as in performance, Simon, but the speed of just like work not done, things not figured out, interface definition files not defined. Is sometimes the most exciting thing.
Oh yeah, and to an extent, we also want to talk about the feedback loop of people or engineers just focusing on the right problems. I know we've spoken a bit about Parquet files, but I think we're all experienced of here's a bunch of random CSV files. Let's pretend to understand them. And one of the things which, if you start thinking about it, is actually close to magic is DuckDB's ability to just read a CSV file. And
it shouldn't be that big a deal in this day and age, but it still is.
There's a lot that's sort of just done for you with the defaults. You'll get it to read a CSV file. It will automatically sample the columns. It will infer, the data types, floats, ints, booleans, and it will project its best estimate on how to organize that table. It'll attempt to find the delimiter, the line termination, whether there's a header, the data types. So what looks like an innocuous, read CSV file, star.csv, it'll jump in, parse a whole bunch of CSV files, sample the top, 200 rows, 2,000 rows, actually doesn't matter, and then make a best guess inference around the data types and the most sensible way to name some of those columns. And again, you are the user of all of this. You're benefiting from a lot of these sort of smarts and heuristics under the covers. And what looks like an innocuous command to just read a bunch of CSV files from an object store or a local disk, suddenly a lot of that sort of annoyance and drudgery of trying to work out, well, is this one tab delimited and this one's a Boolean, but this one's called a flat. A lot of that stuff is just, abstracted away from you, and you can actually worry about what you were trying to do in the first place, which was, get the data and do something with the data instead of having to arm wrestle a lot of data types under the covers.
Yeah. That's oh, sorry, Chris, I was going to say that's the CSV sniffer feature, which you can look up the documentation around it. It's actually quite while it is quite automated and gives you all that powerful auto detection features, it has a bunch of neat features as well. Like you can actually see what settings did you automatically infer for the read CSV function, and it'll spit that back out at you, which then you can actually reuse that later. So you're no longer sort of relying on that it did sniff the right set of formats. Now you've got that robustness into your pipeline.
Yeah, you can take the guess and then freeze it so you're not guessing anymore.
Exactly, yeah.
I like that. It's funny. I wonder if this comes from the fundamental design decision of, if you're a transactional database, you kind of assume that your user is defining the schema and they're sane. But when you're an analytics database, you kind of have to assume crazy, dirty, real-world data, right? And it shapes the whole way the product comes out.
Yeah, I think there's a lot. There's a lot to that. Firstly, I think you're right. I think that sort of persona mapping or the use cases really sort of driven a lot of the development for solving a lot of the paper cuts. And here's a typical path. Let's try and solve for the 90% path, but also give enough sort of optionality if you do need to override it or whatever. And just the ergonomics of making that simple. So all of the defaults are sensible. The idea that you might want to do this in an experimental way and then have a robust way. Again, those ergonomics are expressed sort of nicely. So yeah, I think that's just a nod to some thoughtful design with a focus on who's actually going to use it and who's going to have an easier time, but just by sanding away some of those paper cuts.
Yeah.
It's a good point you make, though. I think, Chris, that I hadn't really thought about in the sense of that distinction between transactional data and analytical data, and this sort of challenge of messy data. I think you're alluding to this. If you look at a lot of transactional database use cases, they're inside the context of some application. It's an application database, which means they have been quite well designed with a formalized schema, and that's published, and everyone knows that if I want to use the user table or whatever it is, this is the schema, and this is how we're using it. In the analytical world, it'd be nice if that was the case, that we always had these well-defined published schemas, but we have this sort of challenge of data coming from different sources around the organization. Sometimes it's just random weird sort of extracts from Excel or CSVs, but also other operational systems. I think one of the interesting features is that you're often working with data that you don't own. So you don't it's coming from some employee records, ERP data, or Salesforce or whatever it might be, and that schema is defined by another team. And one day they might roll out some change to the schema, and then, oh, sorry, we forgot to mention, that, we were going to do that. And so for anyone who's been paying attention to all of the interest around data contracts and thinking about, hey, let's make your data, operational data as a product, and let's sort of have contracts and SLAs and things like that. If everyone was doing that, then this would be a little bit less of a challenge. But it turns out coordination at scale in organizations is challenging.
Sometimes think that's the whole of the challenge of organizations at scale, right?
It's a recurring theme.
Yeah. So that definitely raises the question of sooner or later your luck will run out and there'll be a format that DuckDB doesn't support. Have you looked into writing extensions to support an entirely new format of data? Or is that something you go to a programming language for?
I think just personally, I haven't written an extension, but maybe just to orientate this conversation, one of the fabulous things about DuckDB is it is extendable and extensible. So this sort of idea around there's an extension out there to solve your particular problem is just like a nice little piece of optionality with DuckDB. When I started mucking around with DuckDB, the JSON reader was an extension, and you'd choose to sort of include that before you did any JSON processing. Over time, I think that that functionality was so useful, it's now a default extension. But there's a bunch of other extensions that I've been playing with recently to handle a particular type of geospatial data called H3. And again, this is people much smarter than me who've know this space, who've written an extension, have sort of abstracted away the problems so other people can benefit from this research. And from my perspective, I simply install an extension and suddenly I'm mucking around with geospatial data like I understand what I really should be doing. But it's, again, just a great way of, here is a problem space. there is an extension. I can load that extension, and suddenly I'm dealing with essentially a new data type that wasn't part of the default DuckDB installation.
Yeah, I hadn't come across that data type either, the H3. And the reason I found out about it, I think we're both having just learned about it, is that so that's actually a community extension for DuckDB, and DuckDB has recently released its community extension repository. So I guess if you've used Python, it's sort of similar to PyPI, where people can create extensions, upload them, and then install them from within DuckDB. So you actually have them published. And so it's probably worth distinguishing that from, as in contrast to the core extensions that the DuckDB team and project maintain themselves. So there is also the spatial extension, which is core. You have to opt into installing it and running it, but it does give you a bunch of really awesome spatial features out of the box. Well, out of the box once you install the extension, which we have a section on some interesting use cases around that in the book.
So there are other people's extensions, so there must be some mechanism of creating them. But then there's always the fallback to you can write a programming language. You can use a programming language to write data into DuckDB, right?
That's correct, yeah.
And I know, Ned, you've been diving into, of all things, R for that. Tell me something about using R with DuckDB.
So I guess, an alternative query interface to interacting with DuckDB. Totally. So I guess full disclosure, I've primarily used Python for all my analytical data adventures for quite a while, and I've lots of people I know have use R and have had very good things to say about it, and wanted to put something together for the book. So wanted to really have hey, how can I get started using DuckDB and R and put it through its paces? And so I actually, rolled up my sleeves and got down to business and learned a bunch of R. And I was really, really quite delighted by so it's this library called dplayer, and it's a interface for doing analytical queries. And it's a really very, very well designed. You can see a lot of thought has gone into, let's decompose how we assemble queries into these a grammar of data manipulation. And so that we know we have things like filter operations, and we know we have things like select columns. We know we have aggregation, and where we're grouping by certain things. So let's have these primitives that we can compose as in a pipeline. And so you actually have this pipe operator. And so if you've got it all leanings towards functional programming, it feels very familiar and nice and elegant, where you're actually composing these pipelines. And the nice thing is that what that means is that you can then, hang on, I'll take one step back, is I guess if you're doing that, sort of perhaps the default experience of doing that is using that interface to write queries over the data frame library in R. So in Python, there's pandas and polars data frames. So that's kind of what you're manipulating, these data structures. But it turns out that you can use this nice dplayer library with this really cool interactive grammar manipulation language against other targets, other backends. So there's yet another library, often these sort of things playing together, called dbplayer, and it allows dplayer to target different SQL backends. And so DuckDB has good support for this. So what that means is once you get to the end of this sort of set of composed queries of different primitives, dplayer can sort of collapse them all together into a logical query and then work out, well, what's the right DuckDB SQL that I need to generate for that, which you can inspect if you want or run. So you sort of get all of the benefits of that nice interface, but then with the performance benefits of DuckDB.
Do you find, so you've used this on R, which is very different to a SQL interface, which again is very different to the Python library?
Yes. And before we jump into Python, I should also mention DuckDB. They've actually, I think in collaboration with Posit, they've produced DuckPlayer, which is like dplayer, but instead of generating SQL, it's actually targeting the internal DuckDB native API.
Oh.
So it's the same benefits. The user shouldn't really notice much of a difference, but you don't have to do this sort of intermediate step to SQL. And so it'll be a bit more performant. And then you don't have, that intermediate abstraction layer where you might get weird errors from a SQL engine in your dplyr error, where it's like, actually, you get nicer error messages without that intermediate level of abstraction.
I wonder if this is a thing of the cloud age where everything is becoming like just one core piece with lots of pluggable bits. So you can imagine DuckDB having its own storage but not necessarily using it, having its own query layer but not necessarily using it, and someone, I don't know, a closure person using data log against DuckDB's query engine for the sake of Postgres or something.
Oh, no, it's absolutely a thing. It's happening. There's a relevant tool is Substrate, and it's all about serializing query plans. I think there is support for DuckDB and Substrate. It might be sort of in the experimental bucket, but it's definitely there, which means that you can, if you target a Substrate query plan from DuckDB, you can then go and run that in other engines that accept that query plan. So it's that intermediate representation of a query.
Well, I shouldn't be surprised that that's happening. Sooner or later, every process gets turned into data and becomes more useful.
Totally. And there's if folks want to go follow that trend, there's a bunch more of sort of breaking into these modular components. And sometimes they get so modular that they're not actually for end users. I forget which library it is. I think there might be one that's backed by Meta. I can't remember which bit of the stack they're sort of pulling out, but it's basically like, as an end consumer, you're probably not going to use it. But if you're building your own data engine, distributed sort of analytical engine, maybe you could build on that.
Yeah. Lots of functional programming language jokes about things getting so abstract and pure no one's actually expected to use. Perhaps we should pull it back to something more concrete and everyday, and the Python library, which has got to be, like, if we're talking about analytics and data scientists, we have to dive into the use of Python with this. Is that which of you two is the Python API expert?
I'm going to give Ned the talking stick for this one.
I did the Python chapter. It's I really like the DuckDB Python client. There's a little bit of surface area to it, and it can take a little bit to get your head around it. But some of the basics, like to hit the ground running and just start using it, doesn't take very long. I think one of the really nice features that that you get from the Python client is the relational API, and so when you write a query using the relational API, and I think I would recommend most folks to, like, unless you have a reason not to use it, just default to using this. You can write a query, whether it's with SQL or a non-SQL way of doing it, which we can get back to. The result that you get isn't actually a chunk of data that's been fully processed, like a complete, data frame-like object. It's a relation, which is an abstract representation of the query. If you're looking at in a notebook, you will see the first lot of data. I think it's up to about the 10,000 records. And that's because, hey, I want to actually see what I'm doing as I'm prototyping. But if you're working with million, potentially billion row data set, you probably don't want to be materializing each query fully. So you get this lazy representation of your query that will, until you ask it to actually, fully materialize or just peek at the first bit, it won't evaluate anything. But then you can start doing interesting things with that. We can run a SQL query, and then we get the result of that back stored in a relation. Like, there's just a variable assigned to this relation object, and then you can actually query that relation object. You can do, select star from the variable name of that relation, as long as it's in scope in your Python process, notebook, what have you, and it'll actually start pulling data through essentially a composed pipeline. To me, it sort of feels like this is how you can, as a Python programmer, I'm like, well, this is kind of how I might decompose, code into functions. I can decompose queries into these logical blocks.
Yeah, because the thing about SQL, I really like SQL, but one of its drawbacks is it doesn't really compose, right? And do you know if under the hood that's still managing to optimize the final query as a whole?
Yes, it does. So it will take the sort of the final yield of that chain that you've composed, and then it will the query planner. And so this is actually you've hit the nail on the head. This is a great reason to be using it, because that final composite relation, the DuckDB query planner can now do its magic and optimize it for you. So there's more more opportunities to do those optimizations.
This is reminding me of my own use case, but maybe I'm going to pick on Simon and we can talk about this for a bit. The idea of embedding into a Jupyter notebook.
Mm-hmm.
So I've had a lot of fun with DuckDB embedding it into a web page.
Have you been using the WASM?
I have.
Executable?
It's the thing everything needs to compile to these days in order to be hip.
Absolutely. So WASM, WebAssembly, I think it is the shortcut for WebAssembly. It's essentially, as I understand it, a bytecode runtime that can sit in a browser. And DuckDB, you can pip install it, you can put it in your R library, but there's also a runtime compiled into WASM. So yes, your browser can natively run a full DuckDB installation, and this to me just blows my mind. You have a very powerful runtime, which is a standards compliant web browser. You can bring in WebAssembly code. So DuckDB, compiled as a WebAssembly, can sit there in a sort of a sandboxed area of your browser. And you really can hit up public endpoints such as APIs, public or object stores, bring in data, and everything that we've been talking about writing SQL and extending DuckDB, you can do while DuckDB is running as a WebAssembly within a browser. And this to me just I just find astounding, incredibly cool, but astounding. Yeah. And WebAssembly is super neat in itself. It's a sort of got a, depending on the browser, got a virtual file layer, so you can read and write files off a virtual store. So if you've got a fairly modern web browser, when you export or import data or write and read Parquet files or CSV files, it's running in your browser against a local file system presented by your browser. And this is a fairly cool and novel thing and quite a useful thing to play with, but it's got some real world implications, which some vendors are now using in their sort of high performance visualization and notebook experiences. I might be getting this wrong. I think it's Mode, who's been public with some of their analytic environments, which are essentially WebAssemblies, which allow the outward experience is very fast processing and analytics and carving out of data. But a lot of this is implemented using WASM just to sort of speed up that interaction. So I might be getting the vendor wrong, but some of those
I dug into that one actually, because Mode have a blog post on that, and they did absolutely switch to using DuckDB. I think it might be more of a server-side thing using the JDBC connector, so it's a bit more like a BI sort of, think of having DuckDB being your data cube that you plug into an interface they might already have, unless that's changed, and they could also be WASM now. But there's a few others, like there's an open source library called Observable, which is doing some really interesting stuff around BI, business intelligence as code, and so kind of helping spin up dashboards and reports with Markdown and inline code. And actually, I think one of the things they might have come out with recently is when it used to be sort of static reports, but now the thing that you spin up is actually a interactive app, and I believe that is using WASM, DuckDB WASM.
Yeah, so that is my use case. So maybe I should get observable on the podcast, because it's just this really nice thing of like, I know how to spit all my data to a web page, and now I'd really like to just write an SQL query and see a pretty chart.
Mm.
And the fact that you can power all of that in the web page is really cool.
That's right.
And also the fact that you can like have SQL running in the client and not have security issues.
That's right. Because as you can imagine, web browsers work in a very hostile environment. A lot of safeguards and virtualization you get for free by using a web browser. And the fact that you have a very powerful runtime is just like a really nice opportunity to get the best of, high performance data processing with the convenience and essentially the ubiquity of browser runtimes. And by browser runtimes, we're talking, desktop browsers right down to Android phones. So you can literally run DuckDB in an Android web browser.
So maybe we should talk about that, the kind of performance overhead of actually running it. Do you know anything about like the size load, the performance load that shipping a DuckDB to a user would cost?
It does take a bit of a hit at load time, because you've got to pull down the DuckDB modules, libraries, and I think that's kind of their recommended advice is if you need sort of snappy page response, that might not be the right tool, because it's sort of, I think they've erred a little bit more on the side of let's just include the kitchen sink. Like we want to give you an analytics sort of workbench. So we're not going to kind of prune down DuckDB. There's obviously, as Simon mentioned, there's a few things that because you're working in a browser sandbox, you can't. There's some constraints that you have to work within, but it does give you most of a full DuckDB. So I think that's probably one consideration is the sort of the load time of your page. But if you've got a bit of tolerance there, it's a pretty good use case.
Yeah, maybe for company intranets, it's a non-issue. For user-facing stuff, maybe you could just download it when they download an app. That'd be interesting.
I'm sure there's some clever workarounds, but it's definitely something to be mindful of as a potential drawback.
One thing I'd be curious about, and I throw this out in case either of you have thought about it, is sticking it on something like an embedded chip, like an ESP32 or something. Obviously, it's going to work on a Raspberry Pi. Have you ever heard of anyone using it on something smaller than that?
I'm certainly aware of running it on a Raspberry Pi. Whether it can compile down to a microcontroller down to an ESP32, not entirely sure. It's not.
We'll leave that one as a research project.
It can run in a lot of places. It might be pushing it. Yeah. It is worth mentioning that like the reason why it's like almost like maybe is because it runs in a surprising large amount of places. If you're talking about DuckDB core, it has 0 dependencies, so it's all written in C++, and that means that it's. So I think the dependencies that they do need for that core are vendored in, which means that it's easy to cross-compile without sort of challenging compiler chains to wrangle. And so if you jump onto the DuckDB documentation and look at the number of official, but then also community supported clients runtimes, there's so many that it's which is one of the really awesome things where it's like it's like if you've got a terminal somewhere, there's a good chance you're going to be able to get DuckDB and pull it down and start using it.
That's cool. One place I wonder, and maybe this touches on the limits of it being an analytics database and not a transactional database, but would you ever use it as a kind of smart embedded cache? I'm thinking something like RocksDB. Would you use it in that kind of space, or would the transactional writing capabilities just not be suited? Simon.
I'm not sure about that specific case about maybe cache. I am aware that a number of companies have done sort of edge processing, essentially to try and take what are sort of very noisy endpoints and then lift out the signals and then move those sort of signals down to combined warehouse analysis. So one of the public use cases I'm across is Okta. So folks might be familiar with that cloud authentication software.
If the single sign-on thing.
Single sign-on.
Yeah,
If you work in an enterprise, you probably have used Okta as an end user. I think under the covers, it's kind of like a really interesting use case. I believe there's some public blog from the folks over at Okta where they're literally talking about trillions of records being processed on multi-millions of object stores. And their use case is roughly along the lines of they have some extreme high throughput collection agents which sit at some edge nodes. It's probably cost prohibitive to literally bring in trillions of rows into their cloud data warehouse, but they do actually want to pull out some signals and some aggregates. So they use DuckDB for some of that sort of pre-processing and normalization and operational metadata. And then I believe that gives them sort of a good sort of trade-off between trying to process everything and trying to find out where there's some interesting noise or sort of heuristics or data to dive into. But yeah, it's a really interesting use case to think about. Well, maybe there's times where you've got some processing, maybe at the edge, and maybe you don't want to slurp all that data back into a centralized place, but you're happy to bring in the high-level aggregates. So there's maybe not so much cache invalidation, but aggregating data at scale is definitely a use case that's got some traction.
Okay, that's definitely something I can use on my probably still Raspberry Pi sensor out in the field, right?
Yes.
Before it starts uploading stuff.
Yeah. But I don't think you should stop there, Chris. I think you can set it as a hobby project to cross-compile down to an ESP32 and see how you go with that.
I think you're making a mistake about how much spare time I have in my life, but I'd definitely be interested. So speaking of spare time, thank you. You've given me a segue into what you've been doing with your spare time. Because I definitely want to know, as well as the technical side, the whole writing a technical book and collaborating on it. Because it seems like a double-edged sword, right? If you want to write a book, getting someone to do half of the work seems like it's going to be easier. But then coordinating it seems like more trouble than it's worth. I mean, Ned, give me your experience. What's it like to write a book with Simon?
It was definitely an experience. Look, I think covers all the gamuts. Look, on the whole, positive. We definitely had challenges. I think for me personally, I the last thing I wrote was my PhD thesis. I guess it's been enough years that I've sort of, amnesed the pain. It was like, oh yeah, I could write a thing. Simon didn't have any excuse and hasn't. So he was
ignorance is bliss.
Exactly. So yeah, look, it absolutely was really. Look, I think we, as I mentioned earlier, we sort of tried to approach it from that. Broadly in DuckDB, there's sort of two sort of families of use cases: supercharging your analytical workflows for sort of data scientists, ML engineers, data analysts, and I was sort of wearing that persona, that hat, in terms of what I brought to the book, and the other application is using it as a building block for data infrastructure and data products. And Simon brought his data engineering hat, and so we did a bunch of the dividing up of the topic areas. We each drove certain chapters, like we collaborated on all of it, but we were researching and driving specific chapters. And so that was really good because there was stuff there that was just outside of my wheelhouse, and I was learning from Simon as we went along. And that was really great. I think there was interesting challenges around. I think we have different sort of working styles. I will confess that I think that the book ended up being as heavy as it is. I think that's definitely on me. I'll put my hand up. And there was sometimes there where I was like, maybe I should have actually been. I probably needed a blog. Some of this maybe could have, gone into a blog, but I had a place to write words, and I kept. And look, to be fair, I think there's interesting stuff in there, and the book is meant to be. Now I'm like, oh, do I need to defend myself? There's something in there for everyone. So, but yeah. That's yeah. What about you, Simon?
Well, firstly, I say that the writing experience has been wonderful working alongside Ned. I did actually just want to underscore a couple of things. One of the things that we were aware of when we started writing this book is we didn't want to position DuckDB poorly. And we thought if we wrote it from a data engineering perspective, we might be sort of misrepresenting DuckDB as a database. If we wrote it from a data science or an analytics perspective, we might be pigeonholing it. So when we were trying to work out the content and the coverage and the practical nature of using DuckDB, we kind of wanted to cover an awful lot of territory to do what we thought was justice on a very flexible tool. And I think we realized that to Ned's point, that to do justice here, we really did need to approach this from multiple angles, thinking about this from different personas. And to Ned's point, we did actually want to do essentially some practical material which is going to be useful for analysts and data scientists and engineers and folks who just want to get a job done. So yeah, to Ned's point, I kind of wrote some of the more data engineering and SQL style chapters and things like explain plans and partition and pruning and Hive meta stores. That's very valuable to explore, but we didn't want that to be the beginning and end of the story, which is why it was so important to understand all the things that Ned could speak to, which is a lot of the understanding and ergonomics and mental frameworks to really express what it means to talk about some of those APIs and consumption frameworks. And also, I didn't want to write the chapter on R, so I was more than happy to pass that to Ned.
Yeah, that's one fair way to divvy it up. Did you find, did the tone of collaborating change when you started to reach the editing phase? Is it all you can imagine that as someone who's written plenty of pull requests and received plenty of code reviews, there can be sometimes you can find out that people are really different people than you thought when they're reviewing what you've created. I
have to say it was an absolute, I'm going to say a joy in the rear vision mirror perhaps, but I appreciated the writing phases, but I also appreciated getting feedback on the things I had written because it showed some blind spots. It showed maybe what I thought was crystal clear could require a bit of elaboration. And sometimes there was stuff that I was really passionate about and to another audience was maybe a bit sort of verbose and could be condensed. So it was somewhat challenging, but I did appreciate that sort of back and forth, which I think really sort of refined the book. And the opportunity to review things. Writing a book gives you an opportunity to learn so much. And I really appreciated having the opportunity to provide feedback because it was some depth and experience and expertise that I essentially got for free while writing the book by just reviewing some of the things.
It's an interesting definition of free, Simon.
Time's free, right?
Yeah, right? Yeah. No, but yes, I 100% agree with that. For me, I really wanted to go deeper into what DuckDB can do, how to use it, and also, some of the surrounding concepts and approaches in dealing with analytical data that I haven't sort of been as exposed to previously. So I think I very much learned a whole bunch from Simon in the process.
Well, there's a faux pas where you ask someone if they're thinking of having a second child too soon and they're still getting over the trauma of having the first one. But I hope at some point the two of you collaborate again.
Yeah, yes. Well, it's it does. The book does say first edition on it, and we're like, oh, hang on, that's a bit presumptuous.
Foreshadowing.
Yeah. Well, I think we ended up, the timing worked out quite well for us, which is that we, I think, targeted version 0.10 point something, but that was positioned by the DuckDB project as specifically from the delta from there to 1.0 would be performance and stability enhancements. So the API, there were no additional features added, no backwards incompatible changes, which means that for folks jumping into the book, they absolutely should target 1.0. And so I think there's a DuckCon coming up in Seattle soon. That will be sometime in August. This is 2024. So I guess that's where we get to hear, a bit of the roadmap, what's coming up next in the next release. And so I'm really looking forward to see what those features will be. And, fingers crossed, the content of the book remains sort of accurate for as long as possible. But, that's how these things go. They will change. And, we want to see changes where they should go. So if we get to that point where another edition is needed, we'll see. Yeah. We'll see how we're going.
You may find they announce they're doubling down on the amount of R. Then you've got a job for revision 2. Well, I imagine you're planning, are you doing a book signing there? Whether they like it or not, you can do a guerrilla book signing out the front door.
Oh, wait, I don't think either of us are going to be at the DuckCon this one. No. I think there's at least, is it a couple a year? They're regular events, so I'm very keen to make it over. It's not always in the same place. If folks want to see what gets on there, the presentations are on DuckDB's YouTube channel. So you can see there's the state of the duck, which is what's going on in DuckDB project sort of now and looking forwards, and then there's a bunch of invited talks from people in the community building on DuckDB or making DuckDB extensions and libraries, and really good talks. So, but hopefully we'll make it to one at some point in the near future.
Well, hopefully they invite you, but I will go and check that out for now. Simon, Ned, thank you very much for taking me through it, and best of luck with the book launch.
Well, thank you very much, Chris. It was so much fun talking to you today. And really, obviously we're passionate about DuckDB and the community and the great open source technology. So yeah, really happy to have the opportunity to chat with you today about our passion.
Yeah. Thanks so much, Chris. It's been great.
Cheers. Bye for now.
Bye.
Thank you, Simon. Thank you, Ned. I'll put links to all we've just discussed in the show notes as usual. And of course, the first link has to be a link to their book, Getting Started with DuckDB. It's available in e-ink and Tree, as you prefer. I'm also going to put a link to Observable in there, which is my personal favorite wine pairing for DuckDB. I think eventually we're probably going to do an episode on that if I can find the right person, but I'll give you the headline. Markdown plus SQL equals nice report with pretty charts in it. That's a really useful tool for me. It's almost time to go, so I'm just going to give you a gentle nudge. I shall nudge your attention in the direction of the like and subscribe buttons, if you're so inclined. And if you're on a podcast app, the rate and review buttons are there. And for all of you, there is a Patreon link in the show notes if you want to support this and future episodes. If you click on any of those links, any of those buttons, thank you very much. But for now, I've been your host, Chris Jenkins. This has been Developer Voices with Simon Aubury and Ned Letcher. Thanks for listening.